dear students. Thanks for watching my videos and subscribing my channel. I will post different classes videos and different timings, so I can cover for all the classes. Okay, share my channel. Thank you. Okay, today we'll discuss about the properties of whole numbers. Okay, so properties of whole numbers. First, if we see the properties, sum properties is the first property we know about the whole numbers. First of all, we already discussed whole numbers. Whole numbers are starting from 0 and it is going on infinitely. 1, 0, 1, 2, 3, 4 and so on it is. It has infinite numbers but starting with 0. Okay, right. So properties first, we'll go for some properties. Closure property. Okay. Closure property, you see that every property we will check under 4 operations. Under 4 operations we will check the property. So first we'll check the closure property under addition. Here you see that the two numbers, you take any two numbers A and B. Okay, two numbers you take from the whole numbers group. Okay, in this whole numbers 0, 1, 2, 3, you take any number, any two numbers and do one operation A star B. I am writing A plus B, A into B, A minus B, A divided by B, anything you do. If this one belongs to same whole numbers group, A and B are belongs to whole numbers, and then A plus B, A minus B, A into B, A divided by, if every operation number if belongs to whole numbers, then we can say that the closure property is satisfied. Okay, so just we'll check one by one operation. First we'll go for addition first. You take a two numbers 2 and 3. Two numbers you add 2 plus 3. This gives a 5. 5 is again belongs to the whole number. So 5 is a whole number. So when you are adding the two whole numbers, every time it gives a whole number only. So we can say that the closure property satisfies under addition. Next, under subtraction, if you take 2 and 3, here 2 minus 3 will be getting minus 1. But 3 minus 2 is getting 1. But here 2 minus 3 is giving a negative number which is not belongs to whole number. This one is belongs to whole number. Any two numbers, when you are finding the difference between them, subtraction if you are doing them, if every time you get a whole number, then you can say it is satisfied. Closure property under subtraction is satisfied in whole numbers. But here you are not getting a whole number all the time, you are getting a negative number, but negative number is not belongs to whole numbers. So this is not satisfied. Under multiplication we'll check. Suppose 5 and 6, two numbers you take. These two numbers compulsory you have to select from the whole numbers group only. Okay, any two whole numbers 5 and 6 if you take, here 5 into 6 you do or 6 into 5 you do, anything, the answer will be 30 only. It means the two whole numbers, whenever you multiply, the product is also a whole number. Product is also a whole number, compulsory. So that's why you can say that this closure property is satisfied under multiplication. Okay, division. Division if I take, suppose 15 and 3 if I take, 15 is dividing by 3. If you divide 15 by 3, then answer will be 5. The same 3 if you divide by 5, the answer actually it is a fraction 3 by 15, nothing but it's a 1 by 5. But you see 5 belongs to whole numbers group, but 1 by 5 will not belongs to, it won't belongs to whole numbers group. So you see that 15 and two numbers you are selected. Any two numbers you can select. Even you take 7 and 2. 7 and 2 you can, if you divide 7 divided by 2, it is exactly not divided, and it is, that will get like a fraction, it is not a whole number. Okay, so closure property won't satisfy under division. Okay, so only the closure property, select any two numbers from the whole numbers group and do the operation. If all the time the answer belongs to the whole number, then you can say that closure property is satisfied. But in a whole numbers group, closure property will be satisfied for under addition and under multiplication. Okay, this is closure property. So we'll go for the second property, that is a commutative property. Commutative property. In this commutative property, you see now, take any two whole numbers, A into B. A and B both are whole numbers. A and B belongs to whole numbers group. Okay, so if you do any operation, A star B and B star A is nothing but, here I am mentioning with a star, star is nothing but any mathematical operation, addition, subtraction, multiplication, division, anything you take, it's, but if you take here plus, here also plus, it means, so we'll check with one example first. Under addition first we will check it. So we take just 16 and 18 if you take the two numbers. So select now A and B, you check A plus B, what is the answer? A plus B 16 and 18, so answer will be 10, 20, 34. Okay, so B plus A, the answer is 16, 18 plus 18 plus 16, so which is equal to 34. You see that however you add the two numbers, all the time you got the answer same. A plus B you add or B plus C. If you make a change in the order of numbers, then also the results get same. This is called commutative property. So here A plus B is equal to B plus A. So it is happening. So we can say that commutative property is satisfied under addition in the whole numbers group. Okay. So we'll take under subtraction. The same numbers if you take A minus B, you take A minus B is 16 minus 18. The answer will be minus 2. This 16 minus 18. But B minus A, you take here 18 minus 16. The answer will be 2. You see that here, when you are doing a subtraction A minus B, the answer got minus 2. B minus A, when you get it, answer got it as 2. And minus 2 and 2 never be equal. So it means A minus B is not equal to B minus A. It means the commutative property is not satisfied under subtraction. Okay, commutative property. In the same way, we can even check under multiplication and division process also. Okay, we'll check under division and multiplication process now here. So first we go for a multiplication here. So let us take little here numbers 16 and 18. Okay, 16 is multiplied A into B. 16 multiplied by 18. So answer will be, okay, 16 into 18. The answer is 10. 16 plus 18. This is actually the one way is the 16 plus 18 is 24 and 6 8s are 48. 288. 288 will be the answer here. Okay. Now 16 plus 8 will, when you are doing a multiplication of t number into t number, you can add 16 plus 8. It's a 24. 24 and 6 4s are 48. So that and this it's together 288. And you can see that b into a is equal to 18 into 16. So that is also equal to 288. So any way you multiply the two numbers, you are getting always equal, same answer. And the same way we'll go for division. A divided by b. Okay, 16 a divided by b. It means 16 divided by 18. So 2 8 is 16, 2 9s are 18, 8 by 9. And b divided by a, it is equal to 18 divided by 16, that is equal to 2 9s are 18, 2 8s are 16, 9 by 8. And you know that 8 by 9 and 9 by 8 never be equal. This is a proper fraction, this is improper fraction. The value of the proper fraction is always less than 1. The value of improper fraction is more than 1. So this 8 by 9 and 9 by 8 never be equal, and a divided by b is never be equal to b divided by a. Here a multiplied by b is equal to b multiplied by a. So closure, this commutative property is satisfied under addition and under multiplications only. Okay, this is a way you can take here. So any two numbers, commutative property means that you take any two numbers and add in any order, but answer should be same. Then you can say that the commutative property is satisfied. Otherwise it is not satisfied. All the time it should get equal. However, whichever numbers you are taken and whichever order you are doing it. Okay, so this is a commutative property. Okay, we'll go with next property, associative property. Commutative property and associative property both are, it's the same only, but in the commutative property we are taking only two numbers, but in associative property we'll take three numbers. Okay, this is actually written in the form that A star B star C is equal to A star B star C. In this star place, again you take a plus. A plus B plus C is equal to A plus B plus C. Okay. So this is the way we are writing, but the meaning is you can understand that associative property taking three numbers you are taking in the group, and these three numbers you add in any order, answer must be same. Then you can say that associative property is satisfied. Three numbers, it's just you can do the addition and you can do the subtraction, you can do the multiplication and you can do the division. Okay, just for example, I will do the addition here. A plus B plus C. Here, suppose we'll take A value is 1, B value is 2 and C value is 3. If I take like this, you add in any order. First you add 1 plus 2 and then you add the 3. So 1 plus 2 answer will be 5. 1 plus 2 order is 3 plus 3. The answer is 6. And 1 plus 2 plus 3, if I want to add 2 and 3 first. So 1 plus 2 plus 3 is a 5, 1 plus 5 answer is 6. If you add that 1 plus 3 plus 2, 1 plus 3 is 4 plus 2, answer is 6. However you add the three numbers, your answer gets same in all the time in associative property. Okay, so whole numbers satisfy the associative property under addition. At the same time, it also satisfies under multiplication also. A into B into C is equal to A into B into C. Okay, so check the numbers. 1 into 2 into 3. That is 1 into 2 3s are 6, 6 1s are 6. and you check here 1 into 2 into 3. Here multiply the two numbers first, always BODMAS rule following, and bracket first 1 into 2. I am doing multiplication first. 2 into 3. 2 3s are answer 6. So three numbers you multiply in any order, answer is getting same. So that's for that representation we are doing the representation like this: a into bracket b plus b into c equal to b into c into c. B into b, a into b is in the bracket here. It means that b and c is multiplying first here and later multiplying with a. Here a and b multiplying first and later multiplying with c. Okay. So this is the way we are doing the multiplications. So, but you check under the subtraction and division. These both will not satisfy under subtraction and under division. Okay, this is associative property. As any three numbers you add or multiply them in any order, then definitely answer will be always same. This is called associative property. Okay. Now we'll discuss about one more property, that additive identity. Additive identity. Additive identity is that which number is called as additive identity, do you know? 0. 0 is called as additive identity. 0. Additive identity. Okay. Zero is additive identity. 0 you add to any number, then your answer remains same. You are getting the same answer here. So 5 plus 0, 0 plus 100, anything, answer is 100 only. The same number gets as an answer. This is called additive identity. 0 plus a is equal to a plus 0 is equal to a. This is an additive identity here. Okay. Next, we will go for one more property, that's a distributive property here. Okay. It also satisfies the distributive property. This is a last property in this. Distributive property. Okay. Now here a into b plus c is equal to a into b plus a into c. Okay, you add and multiply them, or else individually you multiply and then you add, however the answer is same. Suppose we'll take a is equal to 1 and b is equal to a is equal to, we'll take 2, b is equal to 3, c is equal to 4. Okay, so first we'll check the a into b plus c. It is a 2 into 3 plus 4. That means 2 into 3 plus 4 is 7. So 2 sevens are 14. This is the left hand part of this answer. And right hand part will go a into b. 2 into 3 plus a into c. 2 into 4. So the answer 2 3s are 6 plus 2 4s are 8. Okay, so 6 plus 8, answer is 14 again. See, this is called distributive property of multiplication over addition. Okay, even the distributive property a into b minus c is equal to a into b minus a into c. This is a distributive property over subtraction here. Okay, so these are the properties. So closure property, commutative property, associative property, additive identity, and the last one is a distributive property. These are the properties of all numbers. Okay, so Thank you.